In this video, I'm going to explain the 3 cases of the good-suffix rule first, and then walk you through the thinking process behind, and last, explain the Java code line by line. Let's begin. This is the Wikipedia website about the Boy-Moore string matching algorithm. Let's go to the good-suffix rule part. Here, it said the good-suffix rule is remarkably more complex in both concept and implementation. You can see here, there are 3 different cases here. It's a headache for me to read those in words. So let's go to the examples. It will make our life easier. Here are 3 examples corresponding to the 3 cases. Example 1 corresponding to case 1. When there is a suffix, and mismatch happen here. If the matched chunk happens elsewhere in the pattern string, and if the character preceding it is different from the character preceding the matched chunk, and in this case we switch and this chunk to here to try to match again. This is case 1. This example is for case 2. If there is a suffix, and if case 1 doesn't happen, we can check whether there is a suffix matching a prefix. So the matched part is AB, and the suffix is B or AB. We can check whether B or AB happened in the prefix. Here, B happened in the prefix. We can align the same part, that is B, with this one, and B, B, C, D, A, B. This is case 2. The third example is for case 3. The mismatch is here, and so we have a suffix. So we can apply the good-suffix rule. And in this case, there is no case 1 or case 2. So in case 3, the shift length should be the pattern length. So we need to shift all the pattern by pattern's length. This is case 3. There are 3 cases, but case 1 has the most priority, and case 2 has the second most priority, and case 3 has the last priority. So if we need to build the good-suffix table, we can start from case 3. Say we can start from case 3, say 0, 2, 2, 2, 2. And we update if there is case 2. We can update it here. And we can update even more if there is case 1. Let's see how do we make the good-suffix table in case 3 first. We should understand the meaning of the good-suffix table. The index should be the pattern's index, and the value should be the increment value of the text pointer. If the mismatch happened here, there is no suffix, so we can't apply the good-suffix rule. So we just put 1 here. And if the mismatch happened here, then there is a good-suffix F. So we can shift the pattern by the length of the pattern. C, D, E, F. So index is here. And the skip value should be from here to here. And to make this and compare from the rightmost position again. So the value should be the pattern dot length plus the suffix dot length. The length of the pattern plus the suffix of the length of the suffix. That is 7 here. And if a mismatch happened here, then we can still apply the Good-suffix rule. The suffix length is 2, and we still need to shift the pattern string by pattern dot length. In this case, the skip value is 2 plus 6, that is 8. And if the mismatch is here, D is here, and then the suffix length is 3, and 3 plus 6 is 9. If here, this is C, okay, then the suffix length is 4. 4 plus 6, 10, and it's 11. Okay, let's verify. If the mismatch happens here, yes, the mismatch index is, the index of the Good-suffix table is 0, and the skip value is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct, that is 11. Okay, this is the case 3. It's pretty easy to write the code for case 3, so I won't look at the code here. And it turns out that the case 3 is a special case in case 2. So let's look at case 2. Here is an example for case 2. We don't have case 1 here, and this match, and mismatch is here. But there is a suffix, a prefix, same with this suffix. So we should align this same part. Okay, let's check the skip value. It should be this length. And this contains 2 parts. One part is the index move to the last index, this part. This part is the suffix length. If mismatch index is here, suffix length is pretty easy to calculate. And the next part is this part, from here to here. That is this part. And this part is the length of the pattern minus this one. And this one is the prefix that's same with the suffix. So we need to have a helper function to calculate this prefix length first. Now you can understand why I said the case 3 is a special case of case 2, because in case 3 it's 0. Here is 0. Length of the prefix is 0, because in case 3 no prefix equal to suffix. So in the coding part, we can combine case 3 and case 2 together. Okay, let's make the helper function prefix table. First, the meaning of the prefix table. The index should be the pattern index, and the value should be the prefix length. Prefix length is the value of the prefix equals to the suffix. Okay, if mismatch happens in the last index, then we don't have the suffix, so we just put 0 here. Is here, then the suffix is B, and we compare B with original one. Then B equal to B, so the prefix same with the suffix. The value should be 1, and we put 1 here. And if mismatch is here, the suffix is AB, and compare AB with original one. A is not equal to B, so we just use the value of last time, that is 1, here B. And if mismatch, so here is 1, mismatch if is here, then the suffix is BAB, and BAB with BAB, A, BAB, and B equal, so the length of suffix same with the prefix should be 3. And if is here, index 2, the suffix should be AB, AB, and with BA, BA, BAB. Then A is not equal to B, so we use the value of last time, that is 3. And here, if the suffix is BA, BAB, BA, BA, BAB, the length of the suffix is B equal. It should be 5. And if mismatch is in index 0, so the suffix is A, B, A, B, A, B, and the original one, B, A, B, A, B. And A is not equal to B, so we use the last time's value, 5. Okay, that is the prefix table. You can see we can use a loop to compare from the suffix with the original pattern. And if they are not equal, we can just break the loop and use the value of previous time. And if they are equal, then we can update the value to the new one. Let's look at code to count the prefix length. Here I have a variable last index. I don't want to say pattern.length -1 each time, so I use a variable last index instead. I have another variable last prefix length. I set it to 0 because case 2 and case 3 are the same. I'm going to combine the code of case 2 and case 3 together. And case 3 is a special case of case 2 when the prefix length is 0. I have a prefix length table to store the value of the prefix length and set the last index value to 0. This is my main loop. You can see I start from the last index -1 because I have already have last index here. And I set up the prefix length to 0. That's because, let's switch back to the example. You can see here every time I start from the first index. And so I set the prefix length to 0. And if they're same and +1, and in this case, from 0 and same +1, 1, +1, 2, +1, 3, +1, 4, +1, 5. At last, it's 5. have another variable, suffix length. It's pretty easy to calculate. Just the last index minus the mismatched index. And every time I make a new suffix char array in order to compare it with the pattern array in the future. I compare from the first index and to the suffix length. If there is the same, I increment the prefix length by 1. If not, I break the loop and use the last prefix length as my prefix length. And after the loop, I update my last prefix length to the prefix length, and I set a table with the last prefix length. Let's switch back to the example again. Here, every time I compare from the first index, and if they are not different, A not equal to B, I use the last prefix length. And if they are not, I update the last prefix length to this new length, to this prefix length. That's it. Last, let's look at code to make the Good-suffix table in case 2 and case 3. Case 3 is a special case of case 2 when the prefix length equals to 0. And in case 2, the Good-suffix skip table in index k is the pattern dot length plus the suffix length minus the prefix length. Last index, and I set the last index, set the value to 1 because it doesn't have any meaning. And I count the prefix length, and suffix length is last index minus the mismatched index, and Good-suffix skip table in index I equal to pattern dot length plus suffix length and minus prefix length. That's all about the case 2 and case 3. In the next video, I'm going to talk about how to make the Good-suffix table in case 1. Bye.